the last video, we learned this equation. So your velocity in the x direction is the amount that your position changes by, divided by the amount of time that that takes. We're going to do an example problem of two cars driving towards each other. We want to know at what point are they going to crash. Let's say the first car has a speed of 20 meters per second, and the second car has a speed of 30 meters per second. And the cars are separated by 250 meters. Alright, I'm going to choose this to be my x-axis. And I'm going to say that the origin, so the point where it's 0, is right here on the first car. So the velocity in the x direction of the first car is 20 meters per second. The second car is actually moving in the negative x direction. So its velocity in the x direction is minus 30 meters per second. Since labeling them both with vx, the same variable, is going to get confusing, I'm going to put a subscript a, so I'm just going to call the first car a, and I'm going to put a subscript b for the second car, which I'm going to call b. In fact, you should never use the same variable to label two different things. That's just asking for trouble. Okay, we have our problem. Let's solve it. We're going to use the equation we learned in the last video. The first step to solve these problems is to first draw it. I'm going to start by drawing the x-axis, and instead of actually drawing out the cars, I'm just going to treat them as points. Okay, I'm going to also put the velocities over top of the cars. The second step is to actually try to imagine what would happen. We're trying to solve for where these cars will crash, at what point along the x-axis. So let's try to actually imagine where they would crash. Here's the halfway point. Car B is going faster than car A. So I think that they'll crash a little bit to the left of the midpoint. Having an idea of what kind of answer you're expecting can often help you get to the answer. And if you make a mistake and get a wrong answer, you're more likely to realize that you made a mistake. Let's now write down all the things we know. So we know the velocity of car A is 20 meters per second. We know that it starts at 0. And we're going to say it starts at time equals 0. So t1a equals 0. For car B, we know that its velocity is minus 30 meters per second. We know that its starting position is 250 meters. And it also starts at a time of 0. The things we don't know are the position of car A when it crashes. We don't know the position of car B when it crashes. And we don't know what time these cars crash at. So it looks like we're missing a lot of information, but actually it's not as much as it looks like. Because we know that the x position that car A crashes at has to be the same as the x position that car B crashes at. That's pretty obvious. In other words, they have to be at the same position when they crash. So let's just call that thing x2. And we also know that they have to crash at the same time. So, I mean, it wouldn't make any sense for car A to crash at 5 seconds and car B to crash at 9 seconds. They both crash at the same time. So let's just call that T2. Okay, now I'm going to write down the two equations, one equation for each of the cars. Let's start with the first equation. We can simplify this right away by noticing that x1a is 0, t1a is 0, and we know that x2a is x2, t2a is t2. Now looking at the second equation, we know that t1b equals 0. And again, we relabel x2 and t2. Now we have two equations, and there's two unknowns. That's x2 and t2. So when you have two equations and two unknowns, it means you can probably find the unknowns just by doing some basic algebra. So we're going to start with the first equation. We're going to multiply both sides by t2. These t2's cancels. Let me get rid of them. We now divide both sides by vxa. And same thing for the second equation. I'm going to multiply both sides by t2. Now we divide both sides by vxb. Since both of these expressions equal t2, they have to be equal to each other. So I'm going to set these equal to each other. Then I'm going to multiply both sides by vxa and by vxb. So it's going to end up looking like this. I move one of the terms on the right-hand side to the left-hand side. Then I factor out x2. And then finally, I just divide by this factor that's on the left-hand side in order to isolate x2. Last thing, we plug in the values that we have for these variables. and we get to an answer of 100 meters. And we have solved our problem. We said the cars are going to crash at 100 meters. That's right here. So let's take a look and see what happens. Alright, that's all for this video.